Do you remember how to do
I
this?
got I
What did you
got
get?
B.
Sorry,
I
what's
got
your
I
answer?
got B.
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 Okay, let's see. So nitrogen is this. So in energy absorbed is 950 plus. So this is fluorine. It's just F, but there's three of it. Okay? So 150 times 3. So that gives you 1400 kilojoules. Okay,
Yeah.
energy out. Did you get this?
Yeah.
Okay. You have to remember this NF is like this. Okay. So this one has 3 and then here got 2, so you have to times 6. Okay, so 280 times 6. So 1680. You got that? So the energy
Yeah.
change, enthalpy change is just in minus out.
Minus,
Yeah.
which is negative 280.
Yes, correct. Okay, good. Okay, so sometimes they will ask you to they will give you the energy change and then they will ask you to find the bond energy. Okay, can? All right, so hold on. So today we're going to start a new chapter. This new chapter is called rate reaction. Rate of reaction is basically how fast or how slow a reaction occurs. Okay, so for example, let's say, right, I put a test tube here, okay, and this test tube has sulfuric acid, okay, and I put zinc here, okay. Now, will the sulfuric acid react with zinc?
Yeah.
Hi. So you are finally here. Hold on, Caitlin just came. Ijo, you see you're coming later, is it?
Yeah. My dad, I think he's gonna arrive home at 1:30, so I should arrive there at 2.
Okay, I give your notes. I give your notes to Caitlin. You take from her later.
Okay.
Yeah. This is one set for you. This one set for Jofu. We give him the. All right. Okay, so this chapter we're learning now is called rate of reaction. Okay, it's about how fast a reaction goes. Okay, how fast a reaction goes. So let's say I put a piece of zinc in sulfuric acid. Okay, now what happens is acid and metal. I think I taught you all before when you all were in lower secondary. Acid and metal basically produces salt and hydrogen gas. So what will happen is that this zinc will start to dissolve, okay, and hydrogen gas will start to form. So after a few seconds or a few minutes, depends how fast the reaction is, you will have no more zinc. All the zinc will have dissolved and you can see nothing. And hydrogen gas bubbles will start to form and then it will stop. Okay, so let's say you take a stopwatch and measure the time taken. So you press your stopwatch, this whole reaction takes about 10 seconds. Okay. Now, you know that you put exactly 1 gram of zinc inside the test tube. Okay, you put exactly 1 gram of zinc inside a test tube. Okay, now if you are running 100 meters and you take 10 seconds to run that 100 meters, your speed is 100 meter over 10 seconds is 10 meter per second, right now? Okay, so for chemistry, we don't call it speed, we call it rate. So your rate will be 1 gram dissolves in 10 seconds. So it will be 0.1 gram per second. Same concept. Do you understand? So basically, it's how fast something happens. Okay? Now, another way I can measure the rate is from the moment I put in the zinc, hydrogen gas is released, right? So I know that a total of 10 centimeter cube of hydrogen gas is released. So in order to measure the rate of reaction, I also can measure 10 centimeter cube of gas over 10 seconds, 1 centimeter cube per second. Can you understand? Okay, so this is two ways we can actually measure rate of reaction. Okay, the first way is how much reactant is used up over time. The second one is how much product is produced over time. Okay, how much reactant is used up over time. The second one is how much product is produced over time. Can you understand? Yeah? Okay. Okay. Now, sometimes a reaction can be faster, sometimes a reaction can be slower. Correct or not? Okay? So, what is it that affects the rate of reaction?
pH level. Oh,
Okay, so there's only five. So we work around this five, right? Concentration, pressure, particle size, temperature, catalyst. All right. Now, I cook chicken. Okay. So, Caitlin and Ijo. Oh, Caitlin versus Ijo. Ding, 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 ding. Both of them also cook chicken. Go very hungry. Caitlin take the whole chicken. Okay. Take the whole chicken and put in the frying pan and fry it. 1 kg of chicken. She just put in the whole frying pan and fry. Ijo take the 1 kg, cut into smaller pieces. Whose one will cook faster? Ijo's one will cook faster. Okay? Because now remember the fire
larger
is the
surface
same, the
area.
oil. Sorry, what you say?
Larger surface area.
Yeah, because it's larger surface area. Okay? So that's point number one. Okay. Point number two. Now, Caitlin also go and cut the chicken into smaller pieces. Next day, cook again. So both also the chicken is in smaller pieces. Caitlin use big fire. Ijo use small fire. Use a candle. Okay, whose one will cook faster? Caitlin's one will cook faster because temperature. The higher the temperature, the higher the rate of reaction. Okay. Now you are cleaning the toilet. Okay? You want to clean toilet using the soap. Alright. Now, Caitlin used 10 drops of soap in 1 bucket of water to clean the toilet. Okay? Eugeo used 1 bucket of soap and 2 drops of water to clean the toilet. Whose one will clean faster? Eugeo. Because it's more concentrated. The toilet cleaner is more concentrated. Okay? The higher the concentration, the rate of reaction is also higher. Now, do you know what's a pressure cooker? A pressure cooker, normal pot, right? You cover the pot. When it becomes very, very hot, the pot will start to move. And sometimes the water can go out. Correct? That's a normal cooker. A pressure cooker, the metal is really, really thick, and you can cover it like this, and you can lock this in. So when inside here becomes really, really hot and the pressure increases, your cover won't move. So the pressure inside the pressure cooker just becomes higher and higher and higher. So because of that, pressure cooker will cook things very, very fast. Get it? Because you use high pressure to cook chicken cat. You can use high pressure to cook anything. You know the KFC? KFC, they fry their chicken, they do normal fry, They put it in a pressure cooker and fry. So the oil will cook the chicken very, very fast, but it's still crispy on the outside, but it's still moist in the inside. If you fry chicken in the house, your chicken, in order to be crispy on the outside, inside will still be soft. The inside will still be raw. But if you cook too long, outside will be dry. But KFC won't, right? Because KFC uses pressure cooker to cook. Can you understand? Yeah? Okay. Now, enzyme is like something to make the reaction faster by lowering the activation energy. So, for example, you cook pasta and you cook pasta in salt water. Who will be faster? Salt water. Okay? So, we'll talk about that in a while. Okay, so those are the 5 factors. Okay, this chapter finished already. No lah. All right, so that is the general concept. Okay, that's the general concept. How do we measure rate of reaction? And what is the theory behind it? So that's the rest of this chapter. Okay, Ken?
Okay.
All right, so first one. Now, in order to measure the rate of reaction, like this experiment, right, I want to measure the rate, it usually releases gas. Okay, so if you look at this equation, there are 3 kinds of reactions that we usually learn that release gas. The first one is the one I showed you just now, acid and a metal. Remember, sulfuric acid and zinc. What is the gas that was released? Hydrogen gas. So we can measure the volume of gas that is released. Okay, now the second one is acid and a carbonate. You will get salt and water, but you will also get carbon dioxide gas. So you can measure the volume of carbon dioxide gas produced. Okay, can? Right. The third one is this one lah. Okay, it's called decomposing of hydrogen peroxide. So hydrogen peroxide, when you decompose, it produces water, but it produces oxygen gas. Okay, so all of these 3 experiments, I can measure the rate of reaction because it produces gas. Okay, now how can I measure the gas? That's the second question. How do I measure the gas? So the most common apparatus here is using a gas syringe. Okay, this apparatus, this name, gas syringe, must remember. Okay, so a lot of times you will see experiment where they say, oh, what I do is I just put the zinc and I open my eyes and I see. Okay, can. But the problem is it's not accurate. Okay? Another problem is, okay, I don't want to look, I look at the bubbles. I count how many bubbles. So they always say I count bubbles. Then you must say it's inaccurate because some of the bubbles big, some of the bubbles small. Some of the bubbles burst before you count them. So the most accurate way of measuring is using a gas syringe. Okay? Now there are other ways of collecting gas. For example, if you look at your other one, okay, this one is gas syringe. Uh, Look at this. Can you see this one? Okay, how are they collecting the gas? Same thing. So this one is acid and metal. This is a measuring cylinder. They take the measuring cylinder, they put upside down. They fill it with water. The hydrogen gas will be collected here, then it will push the measuring cylinder down. Understand? So which one is more accurate? Using this method or using the gas syringe? Which one more accurate? Gas syringe, of course. This one you must wait for the water to bubble up, the oxygen to bubble up, and then the water must be pushed down. This one not so accurate. Okay, some of the gas might escape. So a more accurate one is, of course, this is the best one lah. Okay, can? Okay, now, another one is this one here. This one here. Okay. When the hydrogen peroxide react, okay, so this is same as just now, hydrogen peroxide. When the hydrogen peroxide react, it produces water and releases oxygen gas, correct? Okay, the oxygen gas will be kept inside here or the oxygen gas will release. The oxygen gas will release. Okay, because here I put a loosely fitting cotton plug hole. Okay, now, because the oxygen gas is released, this whole apparatus becomes heavier or lighter. Heavier or lighter? Lighter. So the mass will decrease over time. Okay, the mass of this conical flask will decrease over time. So that is another way of measuring the rate of reaction. We can use a balance. Balance is usually electronic balance. That means it shows the measurement of the mass. Okay, can? All right. So you guys understand the type of reaction? The type of reaction we can measure rate is this one. Okay, the apparatus is this one like this. Okay, can? Okay, so let's say all the three reactions, whether acid and metal, acid and carbonate, or hydrogen peroxide, I measure the volume of gas that is collected. And what else must I measure? I must also measure time. Okay, so in a result, I will always get this kind of graph. Okay, I will always get this kind of graph. Here is the volume of oxygen or hydrogen or whatever that is produced, and this is time. So as you can see, in order to measure the rate, you see the steepness of the graph, the gradient. So at the start, the reaction is very, very fast. Then as time goes on, it becomes slower. Can you see it? And then slower. Finally, when it's flat, means the reaction has stopped. Can you understand? Okay, so this is what this graph means. You will always get this kind of shape in rate of reaction. Okay? Can I? Okay, now, do you remember the five factors that I just taught you? Concentration, pressure, particle size, temperature, and surface area. Sorry, catalyst. Not today. Now we're going to learn why. Why is one faster? Why is one slower? Okay, we're going to learn why. All right, now, if I have the experiment, like this one, like just not that one, okay? I put zinc, okay, And here I put sulfuric acid. And then I measure the time taken for a reaction to occur. Okay, can? All right. Now, what gas am I collecting? Hydrogen gas. Okay, so I use concentration of sulfuric acid. I use 0.1 mole per decimeter cube. I use 50 centimeter cube of zinc and I use excess, sorry, 50 centimeter cube of acid and I use excess zinc. All right, can? All right, now this first experiment, I do it at 25 degrees Celsius. Okay, and my graph that I get, the volume of gas against time, the shape of the graph will definitely be like this. Okay, it will be the fastest at the start, then slower, 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 and then stop. Okay, so this is at 25 degrees Celsius. I now repeat the experiment. That means same volume of acid, excess zinc, same concentration of acid. We'll repeat at 50 degrees Celsius. Okay, will it be faster or slower? Faster. And then the total volume of gas, will it be the same? Yes, because it's the same amount. It's just faster. So at 50 degrees Celsius, you will get a graph that is faster but ends the same. So this is at 50 degrees Celsius. Okay, so this is what they always ask you to do. They will give you an original graph and then they will ask you to draw one at 50 degrees Celsius. You must show that it's faster, steeper, but then you must show it ends the same amount. Okay, can you understand? Okay, now I'm going to explain to you why, but can you draw this? Can you write this down? Okay, so why is it? In order for a reaction to occur, basically what needs to happen is the particles need to collide. Okay? So, in order for a reaction to occur, particles need to collide. The problem is sometimes they collide with not enough energy. What is the energy needed for? The energy is needed for what? We just learned last week. Break bonds. And what is the name of that energy to break bonds? Activation energy. So what happens is the particles need to collide with enough energy. The minimum energy needed is called the activation energy. Okay? Now, when the particles collide, they have the activation energy. This is called a successful collision. Okay? When the particles collide more often and got more product, we say the frequency. Frequency means how often of successful collisions increase. Get it? We say the frequency of successful collisions increase. Okay, so just now we just learned temperature. When the temperature is higher, the rate of reaction is obviously higher, right? Why? Are the particles moving faster or moving slower? Faster. So when they're moving faster, what energy is that called? Kinetic. So particles have more kinetic energy. Okay, particles have more kinetic energy. Okay, because they have more energy, do more of the particles achieve this minimum energy? Yes. So more particles can achieve activation energy. So in your exam, this is a 3-mark question. Why is it when the temperature is higher, the rate of reaction is higher? Because the first reason is because the particles have more kinetic energy. The second reason is because more particles collide with activation energy. So all of this cause them to collide more frequency or less frequency? More frequently. So the frequency of effective collision, that means a collision that has product, increases. So of course, the rate of reaction also increases. So that is why you have a graph like this, where the where is my wait, okay. So that is why you have a graph like this, one faster, one slower. Can okay. So if they ask you for a 3-mark question, this is how it's explained. Okay, can okay, don't need to copy this, we wait first. Okay, now, second factor is what? Concentration. Now, temperature, right? Anything can be high temperature. Solid can be high temperature, aqueous can be high temperature, liquid can be high temperature, gas can be high temperature. But concentration, in order for be high concentration, what must it be? Only what can be high concentration? Only aqueous can be high concentration. Okay? What about pressure? Who can be high pressure? Only gas can be high pressure. Okay? Now I'm going to draw something for you. If this is two aqueous solution, which one got high concentration? One or two? Two. Okay. If this one is pressure, who has high pressure? One or two? If these are gas particles, squeezed together look like two, huh? So whether it's high pressure or whether it's high concentration, there are more particles in a volume. Okay. So what we say is when the concentration is higher, or when the pressure is higher, the explanation is the same. There are more particles per unit volume. Basically, the particles are closer together lah. More particles per unit volume. Okay, because there are more particles, will they collide more often or less often? More often. So the rate of reaction increases. So your explanation after that is the same. So whether it's temperature, this is your explanation. When it's concentration or pressure, the explanation is the same. Okay? All right, what's the fourth one? Particle size. When the particle size is smaller, like for example, using powder. What is higher? The total surface area. Because the total surface area is larger, the frequency of collision between particles is higher and the rate of reaction is higher. Ta-da! So easy, right? Okay, can you write this down first? Ijo, can you write this down? Catalyst is the only one that is special. Okay, a catalyst is the only one that is special. A catalyst can lower activation energy. Do you all remember what's activation energy? Yes, the energy needed to break the bond. So I taught you this last week. When they were breaking bonds, right, they must collide. Let's say an endothermic or exothermic reaction, same thing. Let's say zinc and sulfuric acid. This is the energy in and then out and then product, right? Not? So the activation energy will be where? Here. This energy going in is the EA. Okay. So in order for this reaction to occur, the zinc and the sulfuric acid must collide with, let's say, 200 kilojoules. You must have 200 ringgit. Only you can buy this product. You must have 200 ringgit. Okay, so very expensive, right? So if 200 ringgit, not that many people can buy. So today I give you discount. Catalyst is like a discount. So instead of 200 ringgit, now you only need to pay 20 ringgit. Yay! I lower the activation energy. I give you a new activation energy. Only a catalyst can do that. Okay, if you want to imagine, right? So basically, this one is breaking bonds, correct? So if someone is running around, very hard to break the arm, right? So catalyst is like somebody to hold the bodyguard to hold the person. Easier to break the leg because I'm holding it. So this is what a catalyst actually does. It gives a platform for them to react on it. Get it? Okay. So when you add a catalyst, an enzyme is also a catalyst. Enzyme is biocatalyst. Okay, so everything I'm teaching you now is called collision theory. Okay, everything I'm teaching you now is called collision theory. Don't, after the question ask you, answer according to collision theory. Then you go, teacher, I don't know what's collision theory. You never taught me. This whole thing that I'm teaching you is collision theory. Okay, so, all right. When you have a catalyst, so this is the last one, when, okay, okay, let me choose a nice color. When you have a catalyst, catalyst is the only one that can lower activation energy. Okay, so when it lowers the activation energy, basically the frequency of effective collision increases, the rate of reaction increases. So the only thing that it can do is it lowers the EA. Okay. So another question they will ask you is, what is the definition of catalyst? What is the definition of catalyst? So remember, catalysts are a definition. You cannot write what you feel. You must write what the actual answer is. So a catalyst, it's a substance that increases the rate of reaction but remains unchanged. That means I use this thing, it increases the rate of reaction, but after when I finish the whole reaction, the catalyst is exactly the same. It doesn't change. Okay, Ken? So this whole thing that I teach you here, this whole thing is, what did I say? Um, Collision theory. Can I understand? Yeah? Okay, so now, using your newfound knowledge, can you try and answer this first question just here? Okay, just here. This one. Just try and read, or even if you cannot answer, just read through the question. Okay? Just read through this question. I'll teach you how to do it. We'll do it together. Okay? So,
Yeah.
okay, what is the name by meant by the term that I literally just told you? Okay? So substance that increases the rate of reaction but remains unchanged. Okay, so it increases the rate of reaction, but itself is unchanged. So what is the catalyst that they put here? The catalyst that they put here is called manganese 4 oxide. Okay, they put manganese 4 oxide. So you have to read it carefully. A student studies the rate of decomposition of hydrogen peroxide using this apparatus. He uses 20 centimeter cube of 0.1 mole per decimeter cube of hydrogen peroxide and 1.0 gram of manganese 4 oxide as a catalyst. This is a catalyst. The student measured the volume of oxygen given out at regular time intervals. Every 30 seconds, he measured the volume, and he gets this graph. Okay? What is the highest rate? Okay, this is just one experiment. One experiment, the highest rate is always at t equals to 0, or you can say at the start of the experiment. Now, in every single reaction, at every single reaction that you will ever do, the start is always the fastest. Okay, the start is always the fastest. In what reaction? Why? Why is it always fastest at the start and then it always becomes slower and then finally stops? Why? The five factors, which one changes in one reaction? Temperature, pressure, concentration, particle size, and catalyst. In one reaction, which one changes? The something must change in order for the rate of reaction to become slower. No? Temperature, pressure, catalyst, concentration, and uh, particle size. Concentration. Okay? When I first start the experiment, the concentration is very high. Okay, so remember, in any reaction, you will always get this graph because, so the rates always decreases with time, always decreases with time because the concentration. Now, you must mention concentration of what? If the question is acid, then you must say concentration of acid. If the question is hydrogen peroxide, you must say concentration of hydrogen peroxide. Basically, any of the aqueous solution, the concentration of the aqueous solution decreases with time. So the key word here is concentration. So the reason why in one reaction it becomes slower, 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 then stop is because of concentration. It stops because something is used up. So it depends what is used up now, whether the acid or the zinc or the hydrogen peroxide. You must read the question and see is used up. Sometimes it's only one reactant, so that one reactant is used up. If it's acid and zinc, then you must see which one is used up. Can you understand? Yeah. Okay. Suggest one method of increasing the rate of reaction using the same amount of hydrogen. But I want the rate to be faster. What can I increase? Temperature.
Temperature.
Yeah. Okay. Increase temperature. All right. Haha, this one I'm sure you all can do, right? This one amount of moles. Remember the three formulas? Ding, ding, ding. If it's an aqueous solution, mv over 1000. If it's a gas, volume over molar volume. And if amount of moles of any mass, it is mass over molar mass. So which one are you supposed to use here? Okay? Okay, you do this. You use mv over 1000 because it's an aqueous solution, okay? So m 0.1, v is 20. 0.002.
Teacher, can I use the toilet?
Yeah, sure, sure, sure. Moles of oxygen. If this one is 0.002, this one is 0.001. Okay? Hmm. And then the volume, you take 0.001, multiply molar volume is 24. No effect. No effect or no change. Can. Okay, so this question is 20 0.1. So now they ask if I use 20 0.2, what will happen? Double lah. 0.048. Get it or not? It's just double lah. Because from 20 0.1, I'm just using 20 0.2. Just double it. Okay. Okay, the student carries out a second experiment to investigate whether another substance, copper 2 oxide, is a better catalyst than manganese 4 oxide. Describe how the second experiment is carried out. You should state clearly how you would make sure that the catalyst is the only variable. That means, Ijo, are you back?
Yeah.
Okay, you got all the answers here?
I wrote them down.
Okay, you understand how to do?
Um.
I
Yes.
mean, yes, okay. All
Yeah.
right, so let's look at this. A student carried out a second experiment to investigate whether a substance, copper 2 oxide, is a better catalyst. Okay, so describe how you can, so you must make sure all your other variables are the same. So this question, they use 20 hydrogen peroxide, you must use exactly the same 20 centimeter cube 0.1 mole, except you use 1.0 grams of copper 2 oxide. You understand? Okay, so 20 centimeter cube of hydrogen peroxide, 0.1 mole per decimeter cube is added with 1.0, right? 1.0 gram of copper 2 oxide. So you see, you're using the same mass, you're using the same volume, okay? The only difference is you're using a different catalyst. Did they mention temperature? Okay, so you mentioned, okay? At the same room temperature as the first experiment. Measure the volume of gas collected at the same time intervals and draw a graph. Okay? Can you understand? So you're using same volume, same thing, same volume, same concentration, same mass, same temperature, and you're doing the same thing. The only difference is your catalyst type. Okay? Okay. All right. Ijo, you done? You get it?
Yeah.
Okay. Now, so this one is a similar question, and I gave you half the answers just now already. Okay? Do you think you guys can do it, and then we can discuss this? Can? It's the page after this. Same paper. The same paper. The next page. Got it? Okay. Ijo, you okay?
Yeah, I swapped to phone because my dad arrived.
Okay, okay. The meaning of catalyst, same as just now, lah. Substance that increases the rate but remains unchanged. Okay. A student adds powdered manganese 4 oxide to aqueous hydrogen peroxide. So the gas that is why the mass of conical flask and its content decreases as time increases. So the mass decreases because oxygen gas escapes. So in this kind of reaction, instead of measuring volume of gas collected, you measure mass loss. Understand? Can? The rate of reaction is the highest at the start. This is what I told you just now. Highest at the start of the reaction. The rate decreases and eventually becomes zero. Explain why is it the highest? Because the concentration of hydrogen peroxide is highest at the start. Okay, why the rate eventually becomes zero? The hydrogen peroxide is used up. Cannot say the reaction stops. It's used up. The reactant is used up. You must specifically say which reactant is used up. Can I understand? Yeah? Okay. The experiment is repeated in an increased temperature. All the other conditions are the same. Explain in terms of collision theory why the rate of reaction is higher at an increased temperature. Okay, so I told you just now already. Okay, at a higher temperature, what is the first mark? The particles have more kinetic energy. Okay, and then more particles achieve activation energy. Okay, and what's the last one? The frequency of effective or successful, effective also can, collisions increases. Okay, so this is a 3-mark question. This is how you answer. All right. The equation for the, okay, did you manage to count? Yeah. Okay. Calculate the number of moles of hydrogen peroxide. So same as just now lah. M V over 1,000. Okay. Okay. Determine the number of moles of oxygen produced. 0.01, 0.005. Mass. Okay, the question asks you mass. So mass has to be moles multiply molar mass. Okay, so moles is 0.005. Molar mass of oxygen is 32. So how much you get? 0.6 grams. Okay. State the effect on the mass of oxygen produced if the mass of powdered manganese oxide is increased. No change. All right. It might become faster because got more catalyst, but just a little bit. Effect on the mass oxygen, but then it has no effect. Okay. Oxygen can also be produced by the decomposition of mercury 2 oxide. So the question gives you here mercury 2 oxide. So mercury 2 oxide, the product is only mercury and oxygen. So decomposition means to break apart. That means you don't add anything. Decomposition, you got no other reactant, just one reactant. So the question says mercury and oxygen. If you write like that, it's why? Oxygen must be O, O2, then balance the equation. Can you understand? Okay. All right. Now, this one is this question is a paper 6 question. It's basically got no theory. It's just the experiment. Okay. And this one also. They are very, very easy. I don't want you to waste time and do it in class because it's just drawing graph, right? Looking at the numbers and drawing graph. You can do it at home. Okay. So can you guys do it at home, these two papers? Can it's two sets.
Okay.
Can okay, Ijo, yours is wait. Kathleen is on the table later, just take. So the other two sets is very easy. Okay, can this one is for Chen En. I don't think you all are seeing him, right? Oh, you got the two of the same one. Can. So I give you extra. Oh, sorry. Does he have all three? Can you check? Okay. All right then. I'll see you next week. Please finish the homework, yeah? Okay. Bye bye.